Hi class, in this lesson we're going to work on factoring and solving with what I call the magic X. Now this may be a different method of factoring than you've used before, but I generally feel that it's a more simple method of factoring than maybe the guess and check method. The guess and check method would have been that you would have put parentheses here, probably put an M here and an M here, and try to figure out what numbers you would put here that multiply to be 3, and then what numbers that you put here that add or multiply to be 28 that work out to add to be 5. So it is a lengthy process, but again, I have an easier method. It starts off with an X. So you write an X, and on top you're supposed to put the product of the 3 and the negative 28. In other words, this is your A and your C. If you were to write this out as in the form ax squared plus bx plus c, this 3 is your A, the negative 28 is your C. This is called standard form for quadratic, by the way. So I multiply the 3 times the negative 28, get negative 84, and then what you need to figure out here, or what you put down here, is your B, your middle term, in other words the negative 5. So now what we're trying to do is we're trying to figure out what numbers multiply to be negative 84. So multiply this way, we'll put a dot there, and add this way to give me negative 5. So you have to work through the factors of 84 that will add to be negative 5. And after playing with numbers, you may have found that 12 and 7 multiply to be 84, and they have a difference of 5. Now the thing that we have to worry about now is which one needs to be negative. Well, if I put the negative sign on the 7, I'd have 12 minus 7, that's positive 5, but that multiplies to be negative 84. Well, that's a problem because I have negative 5. So instead, I need to put the negative on the 12, and that would give me negative 12 plus 7 is negative 5, and negative 12 times 7 gives me negative 84. So that's the first part that you have to be able to understand and do, is put the number on top by finding the product of the first and the last number, put the number that was in the middle at the bottom, and then figure out what your factors are that multiply up, add down. So now, a couple of reminders is that I don't have any x's in my magic X other than the actual X itself. There's no variables here. No variables. Okay? No variables at all. I have too often students that they want to put an X like right down at the bottom here, or they put X's here. Okay? Well, there's no variables here. Okay? So let me pause again and erase. And now we're ready for the second step, or the second big part of the magic X. So the first part is finding the factors. The second part is you're supposed to take whatever this number is in front, 3m squared, cross off the square, just trust me, it works, and divide both of these numbers, these factors, by the 3 and the m. 3 and the m. Okay? And now here's where the magic happens. If you have any factoring or simplifying, do it. Like 12 and 3 should reduce to be negative 4, and the m still on the bottom. Okay? Now 7 and 3 does not reduce. Here's how this works. If you reduce, you do it. If you can't, you can't. That's okay. But here's what happens. This turns into your parentheses. The variable part goes first, 3m, and then this is a positive 7, so you put plus 7. And then the other magical one is it's a negative 4, so it's m minus 4. These are your factors from 3m minus 5, m minus 28. Okay? I know it took a long time for me to explain that, but it moves a lot quicker if you understand this process than it would be to guess and check. Okay? So these are my factors. We're going to hold these and then set them equal to 0. Okay, so I'm going to erase and make some room again. So now once you've factored, this left-hand side is now at this level, and it's equal to 0. Okay? Sorry. Now what I should do is set each one of these equal to 0 on its own. So 3m minus 7, plus 7, equals 0. and m minus 4 equals 0. And then you continue to solve. So the key is here you're supposed to break it up. That's called the zero product property, which means that either the left parentheses or the right parentheses needs to be equal to 0. So 3m plus 7 equals 0, which means I'll subtract the 7 and get 3m equal to negative 7, which means that m equals negative 7/3. And the second one, I just add the 4 over, and I get m equals positive 4. So we have two solutions, negative 7/3 and positive 4. So now we're going to take a look at factoring and solving this problem with magic x. Now notice that this problem is a little bit different than the first one. The big key is right, this one was equal to 0. This one now is not equal to 0, so we need to make it that way. Well, it's a simple process. You just need to bring the 8 over, bring the 12 over. So we do that by subtracting. I got 7m squared minus 8m minus 12 equals 0. Okay, so that's your first step. Then we go back and do our magic x like we did before. So we're supposed to take the first number, times it by the last number. That should give me negative 84. And then I get negative 8 on the bottom. So same number on the top, but we just got to work through figuring out what makes a negative 8. So I work through my factors, and what I come up with is that 14 and 6 multiply to be 84, and they have a difference of 8. So now I just have to put the negative on the 14, and that will give me negative 14 plus 6 gives me negative 8, and negative 14 times 6 gives me negative 84. So the x part's done. You can see it's a little bit quicker this time. I just need to divide it by this number in front without the square. So divide each of these by 7m. And again, the one on the left happens to reduce, so I can reduce that to be negative 2 over m, because the 7 and the 14 should cancel. Okay, so now I write my parentheses is going to be m minus 2 times 7m plus 6, and that equals 0. Now I set each one equal to 0, so m minus 2 equals 0, and 7m plus 6 equals 0. So now I just need to add 2 and get m equals positive 2, and I subtract 6, divide by 7, and I'm going to get m to also equal negative 6 over 7. I kind of ran out of room, so I'll write it up here. M equals 2 and negative 6 over 7. So I'll just do one more example here. This time's actually a little bit easier because I have a 1 in front. In other words, there's no number in front there. But I still do my magic x. This one's actually equal to 0 for me already. So I take my 1 and I times it by my 120. So 120 goes on top. And then 22 goes on the bottom. And so I just have to figure out what multiplies to get 120. That adds to be 22. And hopefully we get 10 and 12. Now they're both positive, so I don't have to worry about subtracting. So they multiply to be 120, they add to be 22. So now all I have to do is just take this number in front, get rid of the square, and divide both of these by 1b. Well, there's no reducing to do this time, so I just write b plus 10. That came from this first one. Okay, you just write it out sideways. And then you write b plus 12. So again, I'm taking the number that's the letter, putting it there, and the number that's on top goes right after it. Okay, so now I set that equal to 0, and set each individual parentheses equal to 0, and I'll get b plus 10 equals 0, which means that b equals negative 10, and I get b plus 12 equals 0, which means that b equals negative 12. So a little more simple this time, but I'm hoping to just get you to follow the magic x process. If you like to do it the old way of guess and check, maybe you learned in high school, that's fine. This is just a quicker method and seem to come up with less error. So now we're going to solve by the square root property. Solving by the square root property, it happens when you just have a variable squared equal to a number. Okay? Or if you, in the second example, can make that happen quickly. So all I need to do is get x alone. Well, the only reason x is not alone is because I have the square. So to get rid of the square, I just square root. And when you square root something, you get x equals the square root of 5. Now technically, you get the square root of 5, the positive one, and the negative square root of 5. There's 2 square roots of 5. Because if I squared positive square root of 5, I would get 5. If I had the negative square root of 5, if you square it, you'd also get positive 5. So whenever you're solving by square root method, you should get 2 answers, one positive, one negative, plus or minus. Okay, so let me actually show you that. Negative square root of 5, if I squared it, that means I times it by itself. This would give me positive 5, because the negatives would cancel, and then 5 times 5 would be 25. Square root of that is 5. So let's do the second one. And you can see that, first of all, the variable is not by itself, like the first one. It has to be here. So I need to make it that way by moving the 48 over. So I want to add 48 to both sides. And that'll give me 4x squared equals 48. Then I want to further reduce and get the variable all the way by itself by dividing by 4. Then I get x squared equals 12. And now to finish, because I have the square is the only thing I need to get rid of, I square root. And that should give me x equals plus or minus the square root of 12. Just don't forget your plus or minus sign, because you do actually have 2 answers. And this property can be extended to binomials. Notice we have a binomial squared equals a number. The square is alone, so I don't have to move anything. But I do need to get rid of the square, and to get rid of this square, I just square root both sides. And so what happens is my square and my square root cancel, and I get x minus 5 equals, the square root of 36 is plus or minus 6. And I got to be careful because there's 2 answers there, because that means I have more work. So it's really x minus 5 equals positive 6, and x minus 5 equals negative 6. And I do need to actually write it out this way, or at least do it mentally, so that you can see that you get 2 different answers. The first time I'm going to add 5 and get 11. X equals 11. The second time I'm going to add 5 and I'm going to get negative 1. So you need to actually work it out to completion to get your final answer. 2 of them. You get 11 and negative 1. So I'll do another one here. You can see that the 2x minus 3 is squared, so I square root it. Okay, let's do that with a different color. Square root the 18 also. And I get 2x minus 3 equals plus or minus the square root of 18. Now, square root of 18, there isn't a straightforward answer like the 36, so I actually have to try to reduce it if possible. And it does reduce, because I get 18 hockey sticks. You divide it by 2 and you get 9. Divide that by 3 and you get a 3. So that means you actually get 3 square roots of 2. So this turns into plus or minus 3 root 2. So I'll say that's equal to my 2x minus my 3. So to finish, I just add my 3. And here's the thing. This 3 is not a like term with the 3 root 2. So I'm supposed to actually write it 2x equals 3 plus or minus 3 root 2. Okay? So, and again, that's because they're not like terms. And don't try to add the 3 to the 3, or don't add it to the 2, because they're not like terms. To finish, though, I need to divide everything by 2. And this is x is alone now. This is my answer. There's no further way to reduce that. There could be, had there been a different number on bottom, like had it been a 3 out in front, I could reduce them all by 3. But done a Dorito problem, a triangle problem. But this 2 and this one cannot be reduced and simplified. You can't do that. You can't reduce from a root. So this is as far as you can go with this particular problem.